Hello, and welcome to Solving Equations Using Exponent Rules. These examples are of an intermediate algebra level. Let's take a look at rules for exponents. And even though I have them numbered going across, I'm kind of going to go down. We'll see. I don't know. Yeah, probably will go down. So, rules for exponents. Number one, this is called a product rule. If you're multiplying two things with the same base, then you add their exponents. I like to think of this using order of operations. Our order of operations say we take care of parentheses and then exponents and then multiply and divide on the same level and then add and subtract. So what property 1 says is if we're multiplying two things with the same exponent, we step down one level and we add the exponents. All right, so that's step 1. Let's go to rule number 3. X to the m divided by x to the n. If you're dividing two things with the same base of x, you subtract their exponents. So division turns into subtraction. It just steps one level down on our order of operations. And here in number 5, excuse me, that was 3, not 2. Here in number 5, a power raised to a power. So if you have an exponent raised to an exponent, you multiply. So an exponent raised to an exponent, you're going to multiply. And that's property 5. So 1, 3, and 5, I remember all by using the order of operations. We also have the negative exponent rule. If you have a negative exponent, crossing the fraction bar will make it positive. It's also important to notice that 1 over x to the negative n is equal to x to the positive n. So if you have a negative in the denominator, moving that across the fraction bar to the numerator will make it positive. So think of the negative on an exponent as just a direction sign, and the direction is take me across the fraction bar to make me positive. This is a power over a product. If you're multiplying two things and raising them to a power, then you could just distribute that power to each of them. It only happens for multiplication and division, not for addition and subtraction. X divided by y to the m power, that's x to the m over y to the m. Number 6 is a very important property. Anything other than 0 raised to the 0 power is 1. If you want to know what 0 to the 0 power is, come and see me in calculus. X to the 1 over n, a rational exponent. That n denominator becomes the index of the radical. And if n is even, that x value does have to be non-negative, all right, non-negative. So it doesn't have to be positive. It could be 0. Okay, so let's solve some problems. We're going to solve the exponential equations by inspection or trial and error. So this uses a one-to-one property, and I'm going to write it over here since for some reason I didn't have it typed in. You know what? We could type it in right here, and I'm going to do so. I'm going to do it while I'm recording even. And the property says, property of exponentials says that if a to the x is equal to a to the y, then it must be that x is equal to y. That's it. That's the whole thing. And I'm going to make that look all pretty. I'm going to throw it up there into an equation as well. Okay, that's it. That's the whole one-to-one property of exponentials. So what we want to do here, let me get my cursor out of the way. What we want to do here is I have 5 to the x on the left. I know that 125 happens to be 5 to the third power. So in problem A, if 5 to the x equals 5 to the third power, they have the same base, it must be that x equals 3. And this is a factor tree. You could do this to find the prime factors of any number, but sometimes they're a little crazy and hard to do. So I'm going to see if 16,384 is a power of 4. Now I know that 4 to the third is 64. That's a hazard to my job. So now we are at When we multiply by 4, now we're 4 to the 4th. Multiply by 4 again, that's 4 to the 5th. Multiply by 4 again, that's 4 to the 6th. Multiply by 4 again, that's 4 to the 7th. Oh my goodness, it's almost like I planned it like that. So even if you don't know how to factor a number, you could check 4 to the x. My first thought is this some power of 4? And so I'm going to keep multiplying by 4 until I see if I get there. Or if I don't get there, I get a number bigger, and then I know it doesn't work out. But it does in this one. Intermediate algebra examples almost always work out. Now, for example, C, the 10 to the x, that's all cool on the right-hand side. It's the 1 over 100 we need to look at. We know that 100 is 10 times 10, right? 10 times itself, it's 10 squared. But remember that negative exponent rule? If you want to take something across the fraction bar, all you have to do is change the sign of the exponent. So to take that 10 squared from the denominator and bring it up to the numerator, I changed its sign. I now have 10 to the negative 2 equals 10 to the x. So we know x has to be negative 2. That's it. And we could check. Let's say we have 10 to the negative 2 power. Let's say we have 1 divided by 100. Same answer. There we go. And we'll do this again. 3 to the a, that's already in a nice little base, 3 to some power. So let's look at this 1/27. 27 happens to be 3 to the 3rd power. So that's in our denominator, 1 over 3 cubed. That becomes 3 to the negative 3, and we will have 3a equals 3 to the negative 3. So it must be that a equals negative 3. Do not overthink these. It's already giving you what base you should rewrite it in when it gives you that one that's straightforward. See if you can figure out how to rewrite the other number and use negative exponents as needed to come across the fraction bar. Now I have the feeling, I almost started singing to you. That would have been bad. Okay, here we go. Similar to solving absolute value equations, we want to isolate the exponential part to solve. Suppose if I had the equation 3y equals 192. You all know that the first step would be to divide by 3 and get y equals 192 over 3, whatever that answer is. It's the same idea. It's the same idea when we're solving for exponentials. So the first thing we want to do is divide by 3. We'll get 4 to the x equals 192 divided by 3. Let me see. 3 goes into 19 6 times. That's 18. So 19 minus 18 is 1. Bring down the 2. 3 goes into 12 4 times. I mentioned earlier that I happen to know 64 is 4 to the 3rd. And I get x equals 3. And then we could check it too. 3 times 4 to the 3rd power. Maybe I will come out of the exponent before I put that parenthesis on there. And I get 192. Very important. Order of operations. On the left-hand side, I'd really like to multiply that 3 times 4, but that 4 has an exponent. So we have a block here. Because the 4 has an exponent, we cannot get past that level to multiply and divide on the left side of the equation. Therefore, we have to treat it kind of like an onion, peel off that layer and try to isolate our exponential. All right, let's do it again down here. Let's add 240 to both sides. We want to isolate our exponential part. That's 12 times 3 to the x equals 2,000. See, it ends in a 6. We have an 11, 6, 8, 29, 16. But the exponential part isn't isolated yet, and since that exponent is messing with the 3, I can't multiply yet. I cannot multiply 12 times 3 because the 3 has baggage, and the 12 knows better. So we're going to divide both sides by 12. So we'll have 29/16 divided by 12, and we'll get 243. I don't know about you, but I sure hope 243 is a 3 to some power. We know, what would I do? I would do this. 3 to the third is 27. If I multiply that by 3, no. If I take 27 and I multiply by 3, I'll get 81. So that's 3 to the fourth. If I multiply by 3 again, 3 to the fifth is 243. So this is 3 to the x equals 3 to the fifth. So x will equal 5. All right, they will always, in intermediate algebra, they always simplify kind of nicely to get a value we can find. Last example from this section. In order to get 3 to the t by itself, let's subtract 12 from both sides. I have 81 times 3 to the t equals 3. Keep in mind that because the 3 has a t on it, I can't multiply the 81 times 3, so let's just divide that 81 to the other side. But I'm going to use something that we just did up here in this step. It turns out that 81 is 3 to the fourth power. It turns out that on the right-hand side of this, I could write these both as a power of 3. That's 3 to the first is 3. 3 to the fourth is 81. If you need to verify it, it's okay. 3 to the fourth is 81. But I know that in order to simplify two things being divided, two exponentials being divided with the same base, I'm going to subtract 1 minus 4 to get a negative 3 exponent. Oh, it's an ugly 3. That's all right. We'll use it. Which tells us that t equals negative 3. The signs matter. Let's check it out. We could do 81 parentheses 3 to the power of negative 3 because that's what we think t is. Close the parenthesis and add 12. We're really hoping we get 15 out of this. Let's see. There we go. We have the right answer. And that's all there is to solving exponential equations with exponent rules. Thanks for listening.